Have you ever wondered how statistical data has changed our lives and shaped the way we see the world? From predicting weather patterns to understanding human behavior, statistics plays a crucial role in every aspect of our lives. Whether you are a business owner, a researcher, a scientist, or simply a curious learner, understanding statistics is a fundamental skill that can help you make informed decisions and unlock the mysteries of the world around you. Welcome everyone. In today's session, we'll be discussing a powerful statistical tool that can help us establish relationships, predict outcomes, and provide evidence between variables. This tool is called regression analysis. So if you're interested in learning more about how regression analysis works and how it can be applied in biostatistics, then you're in the right place. Let's dive in. After this discussion, you are expected to explain the concept of simple linear regression and its application in real-world scenarios, discuss the two types of relationship and explain the different types of correlation, illustrate the importance of constructing a scatter plot, and finally, interpret and communicate the results of a simple linear regression analysis. But before that, let me introduce the incredible people that will carry out this impressive and comprehensive topic presentation. Abidejos Jude Joseph D, Bakay Jaslyn Myret D, Meridor Ryan P, Oquino Ira L, and yours truly, Pedrera Erwin Ray B. At this point, we are now ready to move further and tackle the concept of regression. Bluman 2008 defined regression as a statistical method used to describe the nature of the relationship between variables, that is, a positive or negative linear or nonlinear relationship. But in this topic presentation, our discussion will revolve mainly on simple linear regression model in which there is only one independent variable and the relationship between the independent and dependent variable is modeled as a straight line. So basically, regression analysis is an extension of correlation analysis. While correlation analysis examines the strength and direction of the relationships between variables, regression takes it a step further by allowing us to make predictions based on those relationships. To illustrate, let's say I am staying in Sagkahan and I want to know the fare rate for a jeepney or multi-cab going to Pleasantville, which is 3 kilometers away from Lady Normal University. Since distance and travel fare are correlated, regression can be used to predict the fare rate. Moving on, we must take into account the two main aims of simple regression analysis, which are first, to understand if there is a relationship between two variables. Again, simple regression analysis is used to explore the relationship between two variables, typically a dependent and independent variable. The aim is to understand how changes in one variable affect the other variable and to describe this relationship using a linear equation. So the second one is to make predictions and estimate the value of the dependent variable. In simple regression analysis, it can also be used to make predictions about the value of the dependent variable based on the value of independent variable. So we can assess the accuracy and reliability of these predictions using statistical measures such as coefficient of determination or the R-squared or the standard error of the estimate.
Two types of relationships. These are simple relationship and multiple relationship. In a simple relationship, there are two variables. These are independent variable, also called an explanatory or a predictor variable. It is a variable in correlation and regression analysis that can be controlled or manipulated. The second one is dependent variable, also called as response variable. It is a variable in correlation and regression analysis that cannot be controlled or manipulated. A simple relationship analysis is called simple regression, and there is one independent variable that is used to predict the dependent variable. For example, a manager may wish to see whether the number of years the salespeople have been working for the company has anything to do with the number of sales they make. This type of study involves a simple relationship, since there are only two variables, years of experience, and number of sales. Also called multiple regression, there are two or more independent variables used to predict one dependent variable. For example, an educator may wish to investigate the relationship between a student's success in college and factors such as the number of hours devoted to studying, the student's GPA, and the student's high school background. This type of study involves several variables. Predictions are made in all areas and daily. Examples include weather forecasting, stock market analysis, sales predictions, crop predictions, gasoline price predictions, and sports predictions. Some predictions are more accurate than others due to the strength of the relationship. That is, the stronger the relationship is between variables, the more accurate the prediction is.
A blessed day to each and everyone. I am assigned to discuss the subtopic of regression, which is the type of correlation. There are four types of correlation: no correlation, negative relationship, curved linear correlation, and positive relationship. As shown in the figure, you can observe no correlation because there is no pattern that can be detected between the variables, or it is a relationship that has no correlation when the points on the scatter plot do not show any patterns. Negative relationship is when the values of the two variables move in the opposite direction, so that an increase or decrease in the value of one variable is followed by decrease or increase in the value of the other variables. As shown in the figure, you can observe three types of negative correlation, which it involves weak, strong, and perfect. These three differ on the way or on the arrangement of the patterns. However, a curved relationship is called curved linear because it approximates a curved line. As you can observe in the picture, you can easily identify that the graph is a curved linear. While positive relationship is when the values of the two variables move in the same direction, so that an increase or decrease in the value of one variable is followed by an increase or decrease in the value of the other variable. As you can observe in the figure, there are also three types of positive correlation, which is the weak, strong, and the perfect. Still, like the negative relationship, you can observe that there are differences in the patterns. And that would be all for the types of correlation.
The independent and dependent variables can be plotted on a graph called the scatter plot. The independent variable x is plotted on the horizontal axis, and the dependent variable y is plotted on the vertical axis. According to Blumen 2019, a scatter plot is a graph of the ordered pairs of numbers consisting of the independent variable x and the dependent variable y. The relationship between the independent and dependent variables can be visually explained using a scatter plot. The lowest and greatest data values of the variables determine the coordinates of the axis, and the scales of the variables might vary. Scatter plots are described as one of the most useful inventions in statistical graphs. Originally, the scatter plot was presented by an English scientist, John Frederick Herschel, in the year 1833. Even though bar charts and line plots are frequently used, the scatter plot still dominates the scientific and business world. It is very easy for people to look at points on a scale and understand their relationship. In constructing a scatter plot, there is just three simple steps to be followed. Step 1 is to identify the x-axis and y-axis for the scatter plot. Step 2 is to define the scale for each of the axes. Step 3, plot the points based on their values. From this nice example of data from the car rental companies in the United States for recent year. The revenue in billions is the y-axis since it is considered the dependent variable, and the cars in 10,000s is the x-axis since it is considered the independent variable. So then, the points are plotted based on their values. Analysis of a scatter plot helps us understand the following aspects of the data. Firstly, the different levels of correlation among the data points are useful to understand the relationship within the data. Next, a line of best fit can be drawn for the given data and used to further predict new data values. Another is that the data points lying outside the given set of data can be easily identified to find the outliers. And lastly, the grouping of data points in a scatter plot can be identified as different clusters within the data. Always remember that in a scatter plot, we use a linear regression. Linear regression line is a straight line that is used to model the relationship between two variables that have a linear relationship, meaning the relationship between the variables can be described by a straight line. A linear regression line can be positive, upward sloping, negative, downward sloping, or flat, horizontal. The regression line can be used to make predictions for the dependent variable.
Thank you so much, Ms. Oquino. So, before we proceed to the interpretation of the simple linear regression result, it is a matter of importance to know what correlation is to be able to understand regression analysis. As mentioned by the previous reporters, correlation shows what type of relationship is present in a variable. In analyzing regression, we can actually use a mathematical equation. However, in this course, we will use a software since it provides a user-friendly interface and a wide range of tools and functions to perform regression analysis quickly and accurately, allowing users to input their data, select the appropriate regression model, and run the analysis with a minimal coding or mathematical knowledge. Therefore, we will explore the use of JASP software to interpret the result of a simple linear regression. In order for us to perform a simple regression analysis in JASP, we have to follow the procedures. We need to open the JASP software and go to the Menu tab, the three bars located at the upper left side, and then we click the next button to create a new project. Take note that JASP does not support Excel file format. Therefore, we have to convert it to CSV or SAV file format. Second, we have to select regression from the analysis drop-down menu and choose linear regression as our analysis mode. After that, we will simply input our dependent and independent variable and the analysis will now run. JASP software will now output various results including the regression equation, coefficients, and measures of fit. These outputs can be used to interpret the strength and direction of the relationship between the variables and make predictions about future outcomes. Now, to gain a full understanding of how to interpret the results of a regression analysis, let's take a look at a sample output. This typical regression result is a representative of what you might encounter in a statistical analysis. In regression analysis, we further explore and examine the contents of the three tables represented in the slide. The first table provides an overview of the regression model, including the sample size, R-squared value, and other measures of goodness of fit. The second table is the ANOVA table, which displays the results of the analysis of variance for the regression model. This table provides information on the significance of the overall model and each individual predictor variable. The third table is the coefficient table, which displays the estimated regression coefficients, standard efforts, t-statistics, and p-values for each predictor variable in the model. The ANOVA table may seem unrelated to regression, but it is essentially similar to regression, although it focuses on categorical data instead of interval ratio data. Basing on the sample output, we can say that the regression analysis found that there is a significant relationship between exercise and physical health, with every 1 unit increase in exercising corresponding to a 0.213 unit increase in physical health. The p-value for this relationship is less than 0.001, which means that this result is unlikely to have occurred by chance. The analysis also revealed that exercising accounts for 9.6 of the variation in the physical health observed in the sample. The F statistics for the regression model is 38.5 with a p-value less than 0.001, indicating that the model is statistically significant and that exercising is a significant predictor of physical health in the sample. Before I end my discussion, let us inculcate in our mind that regression focus on association, not causation. While regression analysis can identify the strength and direction of the relationship between variables, it cannot establish a causal relationship between them. This is because regression analysis is based on observational data and it is not possible to manipulate or control the variables in the same way that can be done in experimental research. In other words, regression analysis can only show that there is a relationship between two variables, but it cannot prove that one variable causes the other. Always remember that with the use of regression analysis, we can make informed decisions, identify patterns, and make predictions based on the data. However, it is important to note that regression analysis is not a perfect method, and there may be limitations to its use. So till our next biostatistics topic presentation, we hope that you'll learn a lot from us. Goodbye and God bless.